This is the third video of content-based recommender system. Now, I would like to explain about linear classifiers. In the domain of data mining, we know that the linear classifiers can be used to distinguish the two classes. Okay? And most of learning methods aim to find coefficient of a linear model. So if it is a kind of classification, so we can just split this by a line, and then the upper side is relevant document and the below side is non-relevant document. So it is a simplified classifier with only 2 dimensions. So it can be split or it can be distinguished by a line. The line has the form like this formula: W1 multiplied by X1 plus W2 multiplied by X2 equals to P. So the X1 and X2 correspond to the vector representation of the document. You can look at the TF IDF. Okay. And the W1 and W2 and B are the parameters to be learned. So if you have already the representation in the TF-IDF, you can make the classification of a document based on the checking. So we have the W1 multiplied by X1 plus W2 multiplied by X2, and we want to know whether it is higher than B or not. Okay. Then in the n-dimensional space, the classification function will be like this one. So this is only 2. Okay, 2 means 2 keyword. Okay. But if we have a lot of dimension or n dimension, it means we have many keywords. We can have the W1 multiply X1 plus W2 multiplied by X2 plus dot Wn multiplied by the Xn. Okay. And then we will have the equation equals to P. The other linear classifiers, you can use naive Bayes classifier. The Rocchio method actually can be used also for the linear classifier. There's another algorithm, we call it Windrow-Hof. The support vector machines is also one of the linear classifier. When we have the linear classifier, we can improve it with a decision model. So we call it the explicit decision model. Decision tree can be used for the recommendation problems. So in the decision tree we have nodes. We have nodes. What is nodes? We have the external and we have internal. The external nodes means the nodes representing the decision. So this is the external nodes. The internal nodes representing the word or the keyword. So inner nodes labeled with item features or keywords. Sometimes we call it inner or internal. It is used to partition the test examples. So we will check whether the keyword is existence or non-existent or not exist. For example, in the first part, I would like to check the word recommender. If the word recommender exists, then we go to decide. If it does not exist, okay, the document is not relevant or irrelevant. Now, if the recommender exists, let's look at the word intelligent. The word intelligent exists, then it is relevant. But if the word intelligent does not exist, let's see the word learning. If the word learning exists, then it is relevant. If the word learning does not exist, then it is not relevant. So in the basic setting, only two classes appear on the leaf node. The external node, we also call as the leaf node. Okay, you may learn this from the data structure, and also you learn this from the data mining class. The decision tree can automatically be constructed from the training data. This one works best with small number of features. If you have the keyword with not so many words, I think this is still okay. And we can use meta features like author name, genre, instead of TF-IDF representation. There's another way to do the improvement by using feature selection. The feature selection, we know that in the data mining, you will have a lot of features, a lot of columns. So the feature selection, we call this is a process of choosing a subset of available terms. If we have the TF-IDF, let's suppose we have the TF-IDF, the keyword, there are so many, and we can select it. How we can select it? We can have some kind of strategy to decide which features to use. So in this paper, feature selection based on the domain knowledge and lexical information from WordNet. So WordNet is a kind of library. And we want to check whether this word is important or not, based on some domain knowledge. Or frequency-based feature selection to remove words appearing too rare or too often. So the word too often means like the the, okay, or off. Okay, so this is too often, so we can remove it. Or too rare, maybe the word diamond. Yeah, maybe it's not that common to use the word diamond. Then, because it is too rare, we can remove it. The feature selection is not appropriate for larger text corpora. Oh, what does it mean? Yeah, if the words or the keywords are too many, so the feature selection sometimes does not work well. Better to evaluate value of individual features or keywords independently and construct a rank list of good keywords. Okay. So it's better if you have the documents that you want to look at, or let's say movie. Okay, so usually we use this as a movie with the movie data set. So you can choose what is the good keywords from the movie. Typical measure for determining utility of keywords, we can use the chi-square. Okay, if you learn in the data mining, I think you learn the chi-square. And then there's also another way, which is called as mutual information or features discrimination index. In this section, I would like to explain only the chi-square contingency table. Okay, in the chi-square contingency table means I have two classes, like class relevant and class irrelevant, and then I have the frequency, how many times this term T appear. So this is the frequency, and then the term T missing. Okay, so it means how many times the term T missing. So this is also a frequency or a number. So if the class irrelevant, then how many times the term T appear. in this case, yeah, how many times the term t missing. Okay. So we can have this number. After we have this number, we can calculate the chi-square with this formula. Okay. So this formula, a plus b plus c plus d, okay, then it is all the values multiplied by the a multiplied by d minus b multiplied by c. A multiplied by d minus c multiplied by d, and then power of 2. And then we will divide with the a plus b. So we want to check only the number or the frequency from the relevant class. And then we want to check from the appeared terms, and we want to check only from the missing terms, and we want to check from the number of irrelevant class. Yeah. So the higher value of the chi-square indicate that the events of term occurrence and membership in a class are not independent. The higher value. So if this, okay, if the chi-square is high, then there is a dependency between the term and the class. Okay. If the value is high, there is a dependency between the terms and the class. Then what can we say about this? If there is a dependency, there are some kind of analysis. First, maybe there are some redundancy. Okay, there are too many overlap keywords. Okay, so if you want to look more about the chi-square, yeah, we can say something, the dependency with the chi-square contingency table. So what is the limitation of the content-based recommendation methods? When we do the content-based recommendation, we use keywords. Okay, so the keywords can be the genre, or the keywords from the movie, or the keywords from the books. Okay, keywords alone may not be sufficient to judge quality or relevance of a document or web pages, because up to dateness. Sometimes the news, okay, or the web page becomes updated, but the keyword still the old way. Then up to dateness is limited. The usability, the aesthetic, and the writing style. The usability means, yeah, we use word which is simple, but some of the words will be complex or not easy to understand. For example, it is too rare to use the word thrill. Yeah. It is too rare to use the word back. Yeah. So because the word is not usable in many occasions, so it is difficult to use this content base. Aesthetic. Yeah. Aesthetic, sometimes in the novel, right, or in some books, they use a very fancy words. Right? So when you use the fancy words, it's very complicated to measure it. And writing style. So your writing style will be different with my writing style. Every person have different writing style. Content may also be limited or too short. So if the content is too short, yeah, we cannot judge the quality. Content may not be automatically extractable. So for example, video or multimedia. Ramp up phase required. So it means like some training data is still required, and Web 2.0 use other sources to learn the user preferences. Now it goes to Web 3.0. Of course, there will be a lot of more resources again, and it can be over specialization. So the algorithm tends to propose more of the same. So if it is the same or similar, we will do the recommendation. Or maybe two similar news items. So it will be more specialization. So the summary, now we can look at this one. In contrast to collaborative approach, it is good because the content-based techniques do not require user community in order to work. So sometimes you don't need the rating, okay? Because you can just look at the profile. You can use the user profile, the gender or the age, and then if the person look at the same movie, then we can try to figure out what will be the future taste of the movie. Okay. So sometimes we don't need rating for the CB. This is the content base. Presented approach aim to learn the model of user interest preferences based on the explicit or implicit feedback. This is another problematic. When we want to derive the implicit feedback from the user behavior, it can be problematic. The evaluation showed that a good recommendation accuracy can be achieved with the help of machine learning techniques. We will learn later about the accuracy. This is the metric in the machine learning. And this technique do not require a user community. So we learn about the TF-IDF, okay, or we learn about the query-based approach with the Rokio methods. So with that kind of method, we can improve the accuracy with the machine learning, but we don't need any rating. And danger access, that recommendation list contain too many similar items. Okay, this is because if you look at the similarity of those keywords or the genre or some other things from the content, there might be too many similar items. So all learning techniques require a certain amount of training data. And some learning methods tend to overfit. So I do not explain in this case the overfit. If you join the data mining course, you will learn about the overfit. Maybe I will just explain a little bit. The overfit means when you train, the accuracy is high. Okay. And when you test, the accuracy is also high. Is it the overfit? This is, we can say one of the overfit. Maybe you can say, oh, why when we say that it is true? Yes, this is true. But usually we have not like this one. We have the test is low. This is the overfit. It will work only with the known data. It will work only with known data. But if it is unknown, cannot recognize the unknown data. So this is the overfit. Okay. If it is overfit, then it means we need to find some other methods, or maybe the way to evaluate the data is not correct. Pure content-based systems are rarely found in commercial system. Okay, yeah, even though it is good, but pure content-based system, pure means only. If we use only content-based system, yeah, it is rarely found. It's not common. Okay. So we can say it's not common. We can do the combination. So we will learn about the hybrid system in the recovery system. So you can look at more things, how the collaborative and the content-based techniques can be combined. So yeah, this is the summary. So you learn about the content-based recommendation system, and you learn about what is content, and you learn about the content representation and item similarities, and you learn about the TF-IDF, which is the term frequency inverse downturn frequency. We learn how to improve the vector space model. So we learn about the stemming, and then we learn about how to remove the stop words, okay, and so on. So the recommending items we learn from the cosine similarity. We can use the nearest neighbor, or how many k, yeah, k and n. If we are using k equals to 3, then we try to find the 3 nearest neighbor, and so on. Rocio's method, so we want to find the query, okay, we want to improve the query. We use the probability method. We have two kind of probabilistic. We have Boolean factor and the terms count. So in the terms count, we also improve the formula with the Laplace to avoid 0. The linear classifier, and we also learn some model like the decision tree and how we can use the chi-square as the feature selection. Okay, I think this is all for this chapter. Thank you, and we will meet for the next chapter in another video. Have a good day.